Hi everyone, welcome to another WAES Tech Talk, and hi everyone here as well. So for today, we're going to have two people presenting. The first one is going to be Eduardo. He's going to present a bit about how you can reduce your costs in AWS using Karpenter. And then we're going to have Fabricio talking about how you can set up your end-to-end tests with Cucumber and Kotlin. So I'm going to give the field for you. Please.
All right. So yeah, first of all, thanks WAES for organizing this event. And yeah, so the title of the presentation is Just-in-Time Spot Instances with Karpenter. You might recognize a few of the terms here, like spot instances, Karpenter, and EKS down there. So let me start by presenting the agenda for today. So these are some topics we're going to discuss and how it's structured. I'm going to start by talking about Kubernetes cluster management, so challenges in Kubernetes cluster management, common challenges. And then I'm going to explain what AWS spot instances are and why they're relevant. And then we're going to discuss, I'm going to talk about Karpenter, so what it is and how it can be used, like to leverage, spot instances and in Kubernetes, in this context, how you can improve things as well or reduce costs. And then we're going to have a little demo. So I'm going to show like in action what it does. Hopefully that's going to make things clearer. So just a little bit about me. These are a few terms that define me. So an AWS cloud engineer first. So I think that's where most of my experience is in AWS. I've worked since the beginning with the cloud, and some other things that I've specialized in over time are like solution architecture, serverless, also relevant, Terraform, and Kubernetes. So that's I think the main one we're gonna discuss today. Some of my interests, so traveling, yes, so you guys know I'm here in the Netherlands, so it's something that always interested me, always wanted to go out and see things out there. CrossFit, boxing, did it for, I don't know, 10 years, 12 years, like as an amateur. Technology, that's what I work with, so yeah, I love it. And gaming. So I'm like a very logical and I'd say number-oriented or data-oriented person. And as such, like I wanted to bring like some numbers here, like why should you be listening to this talk and to me more specifically. So far, I have about 9 years of experience, busy years of experience, and I'm going to explain why. So in college, I've published like 3 research papers. One of them was in AI, but the other 2 were also related to technology. I've worked in 8 different technology companies so far. So they think that's, for 9 years of experience, that's a lot. And I've worked also in other 4 companies, mostly in project management and KPI management. Worked in 14 projects. So in those 8 companies, I've worked on 14 different projects. I think that's also very nice to bring something very nice to bring to the table. And I've studied for 1 year in the University of Texas in a study abroad program as part of my industrial engineering bachelor's degree. And so why is that relevant? Because I wanted also to talk about this. So one thing I firmly believe in is you should always like get out of your comfort zone, because that's when you learn. And that's something I saw, like how much I learned when I moved to the US and studied there for a year. Like I don't think I would ever learn as much if I weren't, out of my comfort zone in a different country, experience things for the first time, and also having another culture. And this is a quote from Karl Albrecht that I thought was interesting. So you seldom improve quality by cutting costs, but you can often cut costs by improving quality. So that's also something I thought was relevant for this presentation, because we are going to talk about reducing costs, but the way we're going to get there is not by cutting corners, it's by improving like the quality of, or how we're dealing with things. And here's some data as well to understand the problem. So Gartner in 2023 had a forecast that the worldwide end user spending on public cloud would be $491 billion. And the actual number was around 563. So compared to the previous year, that's a 20% increase, 20.7. And again, like their new forecast for 2024 is 678 billion. So I mean, year by year, we're increasing 20% in cloud spending. And even now, we have like market is still a little weird, little in crisis. So companies are already looking at ways to reduce costs. And that's why I wanted to talk about like how we can do that effectively. And this is some data from IBM. So IBM, one of their estimations is that they spend, like from the total IT budget, 17% is allocated to cloud, so public cloud. And they have their own cloud, right? So they are pretty good at optimizing their own costs, of course. So usually in companies, you would see, I think, a higher number there. And well, we're talking about costs, but when we're talking about Kubernetes, so Kubernetes runs your applications. And when you look at the cloud costs, most of your cost is going to come from the actual machines, because that's what's running the applications, that's what's doing the calculations, etc. So, and Kubernetes then is really important in that context if you're using it, because it's what's behind, what's controlling where things run and etc. And what are some challenges when you're dealing with like cluster management? So yeah, managing costs effectively while maintaining high performance. So we all know that you can have a good performance if you scale vertically, but it's not good. It's hard to keep costs down and still keep the performance high. Also ensuring scalability when you have fluctuating workloads. So it's very common for companies to have like usage spikes in certain moments, and then the usage goes way down. So to make that scalable and make your workloads, your nodes respond to that, that's one of the challenges. Optimizing resource utilization. So that's also related to like being smarter about, or being more efficient in using the resources you have. So if you have 3 machines, you don't want like one machine that's barely even processing anything. You want all your machines that you're paying for to be processing as much as you need. And yeah, that brings us to spot instances. So what are spot instances? So spot instances are the easiest and I think the most effective way to save costs in AWS right now. So they are basically instances that, EC2 instances that AWS can send a signal that, so they are unused instances that AWS could take back. So they send a signal that they're going to take that instance back, and then you need to like have a process in place to move your workload, and then you can so it doesn't affect your performance or stability. So this is some data from spot instances. So AWS says that they're up to 90% cheaper than a normal instance, than an on-demand instance, and in my experience, it's usually about 65% cheaper. I've never seen like a 90% decrease in costs, but 65% is almost always the case. And these are some use cases where these instances are good for. So they are good for stateless, fault-tolerant applications because, as we mentioned before, these are instances that AWS could take back. So if it's an instance you must not turn off for any reason, you don't want to use a Spot instance for that. And yeah, so you might recognize here for batch processing, Databricks is one of the names now, I think, very popular and very expensive also because you're reading from S3 with instances that are usually big and yeah, to get a good performance out of it. Web servers, so APIs in general, big data and analytics, so also related to processing, and containerized workloads. Containerized workloads means Kubernetes, basically. So yeah, in Kubernetes, your workload needs to be containerized, otherwise you can't run it. So that's why Spot instances are also very interesting for in this context. And what are they not good for? So they're not very good for, well, the inverse of what we just talked about. So basically, if you have a workload that's inflexible, that's stateful, fault intolerant, or tightly coupled, so for some reason that machine needs to be running at all times, then Spot instances are usually not a very good solution. It's not a very good use case for them. And I'm gonna, yeah, so let's explain what Karpenter is. So Karpenter is a cluster autoscaler. Actually, I can see this one. So it's an intelligent and high-performant compute provisioning and management solution. So that means, well, cluster autoscaler. And it helps you take full advantage of AWS. So that means it helps you make the most of all of the resources you're paying for. And here are a few features or strengths of Karpenter. So it responds in seconds, so it's very fast in when your load changes. It can respond really quickly, and this means availability is better. It uses Kubernetes native CDRs, so CRDs actually, custom resource definitions, and they are opinionated by default. So that means that out of the box, you already get a configuration that works in most cases, and then you can fine tune it as you need. And it intelligently chooses the instance types and consolidates pods to lower compute costs. So what does that mean? That means that if it tries to optimize your node usage. So if you have nodes that are very big and you're not using them to the most, it's going to create a smaller node and move your workloads around so you're always using your machines as much as possible, and yeah, paying less for it because then you're not paying for a more expensive machine. And yeah, now I'm going to show it in action. Hold on. Oh. Yeah, this might be easier. So here I have an application, and this application requests one CPU. So that's it. It's just a simple application, so you can see Karpenter working on the background. And this is a configuration. So this is like the custom resource definition for node pool, which is basically how we configure, how we fine-tune Karpenter. So right now, I'm saying that it should consolidate nodes when they're underutilized. So that means it's going to try to move the workloads around to use the instances to the maximum. And I'm going to start with on-demand here in the nodes. And I'm going to say that I want it to create only on-demand instances. And I'm going to scale my deployment here from that application that you saw to maybe 50. And this is another application that I'm using, just so we can see live not only the costs of our cluster, so you can see the costs here, it's about 1.6K a month. And it estimates that with the cost from the instances that's available through the API, so it makes the calls on background and gets that information. And this is the average cost like per hour for the node, for the cluster. So as you can see, it created like this another on-demand instance here. And then, yeah, I scaled it to 50, I believe. So now it's running 60 pods, 0 pods pending. So you can see that it created like a new machine, a new instance here. Let me make this bigger, maybe. So our costs are 1,600 or so, right? So let's see, just take a look at what happens when we reduce the replicas. So now it has 30 pods. You can see that one of the instances here isn't used anymore. So it already removed that instance, and our cost went down like almost immediately. So yeah, that's almost half. I reduced from, I think, 50 to 30 or so. And now let's go back to 50. We had a cost for 50 pods of about 1.6K, but now I'm gonna say that I wanted to use spot instances instead. And then I just apply it, so I can, yeah, it's also as configuration as code. So now it has a few on-demand instances. That's our old configuration. Now that I changed to Spot, soon it's going to start. So in the background, it's looking for cheaper alternatives to the instances we have. Yeah, so you can see that it already found like a Spot instance. It's actually from another generation, like an M5, M7. So it's memory optimized. And it's going to replace one of my more expensive nodes by this other one. So right now our cost went up because it's running, it's moving the pods, but soon we're going to start seeing the cost difference that it makes, you know. So we had 1.6K. It's replacing one of the instances. It's not going to replace all of them at the same time because to maintain availability, so your application is stable. You don't want to be replacing all your nodes at once. So yeah. Oh, actually, it created, I think, one bigger node here and moved more stuff there. We still have one more instance here with 31 pods. It's soon going to replace that one as well. So you see, you already found another alternative. So you can see the cost here as well. So this was costing us 1.22 per hour. This is 0.8 per hour. So probably right now there is a higher usage. So even if it found like an alternative, a Spot instance, but it's not like the cheapest Spot instance that you can find. It's still like pretty like how much? Like 30% cheaper. Yeah, now it's running 2 Spot instances instead of the on-demand instances. So our cost went down from 1,600 to about 1,200. These are still expensive for Spot instances. Usually you get like an even bigger discount. But yeah, so here you can see the usage for each one of the nodes. So it's higher than 50% on all of them. And yeah, so that's it. That's how it optimizes the costs for us. So let me go back here. Not sure about the time, how we're on time. Yeah. So we have, yeah, so that's it. That's what I wanted to show, like how Karpenter works, show it live as well, reducing the cost. We could see it going down from 1,600 to about 1,200. If you have higher costs, of course, the impact is much bigger. But yeah, so that's it. So I want to open for some questions now.
The costs that you expect to be cheaper could be because I see you were using a US West.
Oh, okay.
Yeah. I'm asking question. It could be the business time in US West right now, so more people looking for sponsors.
Yeah, maybe. So what's probably I expected more probably because right now there's probably more usage, so it's harder to find like cheaper alternatives. So it usually tries to find like the cheapest that's available and gets that. So that's why even during like when the usage is high, it could still find spot instances. And yeah, as I said, also it replaces when you get a signal that that spot instance is not going to be available anymore in 2 minutes or so, because that's something unique to spot instances. It already moves your workloads around for you, so you don't need to be managing that. So that's also interesting.
Also, in your experience, do you see difference in price in regions when you are using spot instance, like in Europe or compared to US?
There is a difference in between regions in price, but I haven't noticed like a bigger discount on like one region when comparing with another so far. Maybe it's there, but I just never noticed it. Yeah.
I saw that you put in the demo, you changed the on-demand and spot, but actually you could make it both of them, or you just needs to say, okay, I want only on-demand or only spot instance.
You can use both if you want, and then you can also fine-tune it. So, for example, let's say you have a workload or a part of whatever is running in Kubernetes, you want some of them to use on demand. You can also configure that using annotations. So you can, when you're deploying your, configuring your deployment, you can add an annotation and say that you prefer that workload, you want that workload to use on demand instead of spot, and then it's going to respect that. And when you have both, I believe it just looks for the cheapest alternative, but it doesn't. It also allows, if it needs to use on demand, then it uses on demand. If it's if spot instances are not available, for example, but it also tries to replace that as soon as there is a spot instance available to save costs. So
we also have a question from YouTube. That question from Oscar is: would serverless
also help to lower the costs?
Yeah, serverless is a different approach, right? Because, well, we can use Fargate. Like I have 2 nodes here that are running Fargate. But yeah, serverless is one of the ways to optimize your costs because you only pay for what you're using. So yeah, you pay basically by execution time. So that's optimal as well.
Yeah, talking about reduced cost, we can, as we noticed, we can achieve maybe 25 or 30% reduced cost. But this percentage remains depends on the resources or depends on what?
Well, it depends on what time of the, for example, right now, since they don't have that many spot instances available, usually the discount is lower. So that's why the impact wasn't that high. But on average, it's 65% cheaper if you're using like spot instance when you compare it to on demand. So yeah, it depends on the time of day, but also how much. If, of course, if you're running like way more pods, you're going to have a bigger discount on average, right?
Okay. Does someone else
has questions? No? Okay. Then, yeah.
Okay.
Thank you, Eduardo. Thank you for the presentation.
Let's take this off.
And then for the next, yeah, you can take it. Okay. And for the next presentation, let me just move a bit more. And for the next presentation, we're going to have one guy that already did a lot of tech talks for us. And that's Fabricio. So Fabricio is going to present to us how you can set up your end-to-end tests using Kotlin and Cucumber. And this is your laptop. Do not. Yeah. Is everything okay? Your computer is showing? Just some challenges. Here we're just changing microphones. Okay, there you go. It's not showing there, so maybe you should put it here. So I have two HDMI cables.
I should put this first.
Yes, okay, sure. Okay, the floor is all yours.
I'm showing my bar there. I don't know why the bar is there. One moment. Technical issues. If the bar is still there, it just will be there. Okay, it's not there anymore, so we can start. So, hello guys, thanks for coming here today. Thanks everybody that is watching online. Today, we're going to speak about Cucumber plus Kotlin and a little bit of discussion about how to set up your end-to-end tests in your environment. First of all, I want to introduce myself. So, my name is Fabricio Yamamoto. I am 28 years old. I'm Brazilian. I live here in the Netherlands for 2 years already. And some of my hobbies are drinking beer, climbing, traveling, playing the piano sometimes. I also really like Java, and I still a huge supporter of football club, regardless of the news you had today. And I also really like wearing flip-flops, which leads us to the next item, which is I don't like winter because I cannot wear my flip-flops. And yes, I've tried. So for now, let's take a look in our table of contents. First of all, I want to speak a little bit of test tools and why we should bother about it. A little bit of introduction of end-to-end tests, introduction to BDD. We're going to check them together in the pyramid of tests. And then we're going to have a small discussion about having a test environment that will fit your end-to-end tests in your Cucumber. Then in the item 6, I'm going to show you a bit how to use Cucumber in practice with a little bit of code in item 7. So we are going to actual test on an application that's running in my computer. And then we are done. So by item 8, I hope you have some idea of how to use Cucumber and about how to set up your test environment. OK, let's start. First, about our test tools. Why should we, as developers, bother about testing tools? Even if you're not QA, when caring about software quality, it's very important for us to know that some kinds of testing tool exists. And some of the examples would be unit testing, functional testing, or end-to-end testing, some load performance testing, security or penetration testing. We also have API testing, code quality testing, like we are used with Sonar, database testing, so you can test your queries or maybe your procedures, and even accessibility testing. So if you want to make sure your front end is accessible, you can use a tool for that. But for this talk, we're going to focus on the second item, which is end-to-end testing, and we are going to speak about Cucumber. First of all, a bit of introduction of end-to-end tests. What is it? End-to-end tests are basically a way of testing the behavior of your application in the whole user journey of your customer as a test case. So as you can see in the picture, there is a guy that's going from the start until the end. He's your user, and he's going to use your application. You're going to test the behavior if everything fits correctly until the end. So your tests are green, it's passing. So some pros is that the end-to-end tests, they test the functionality from the start to finish. So it is whole user journey. So it will simulate the user interaction in your application and test the application behavior as a whole. And because of that, we are covering as many components as needed. In this case, you can cover UI, websites, database, APIs, and everything that needs that your application needs to work properly in production. Some cons are that they are expensive, slower, and difficult to set up. And also, you need to have a proper working environment. So you have all these features that you work in Pro. You need to have them working in your environments for testing. It could be a pro, because by having these things, you have a better test environment, which is a good thing for your team. But you need to invest some time on it. Now about BDD, which stands for Behavior-Driven Development. BDD is actually a development methodology, just like TDD. It's a way of developing your application and testing at the same time, and then you keep growing. But in this case, based on behavior. So because of that, it was created this GWT, which are the words we're going to use every time in your tests, which is given, when, then. So given your current state, when something happens, then I expect something to also happen. And there you put your assertions and this kind of things. The pros of the usage of BDD is that it focuses on defining the behavior of the software through natural language, which will help us to have a human-readable format in your tests. And because of that, it's good to cooperate with business parties in your company or in your squad, or even other squads that you need to cooperate. And also, it's a very good source of a living documentation. So it's good even for your own squad. If you're onboarding someone that's new to your product, they can just read your BDD tests and also get to know your product better. Some cons is that they could be difficult to maintain or scale compared to other testing styles. And they are normally attached to some tool or framework. In this case, it's Cucumber. And because of that, you have this initial learning curve. So it's not something that you already know. You have to learn how to work with this framework. So this is a bit difficult as well. But then it's very important to know that end-to-end tests and BDD, they are not the same. We can see in the internet, every time you see end-to-end tests, BDD, but they are actually very different things. One is a test strategy, so it's going to test your application behavior, and the other one is a development methodology. So you are writing tests based on descriptive behavior, but it's like TDD. You are using this to develop your application. But because they are both related to the behavior, they could be really friends and work well together. End-to-end tests and the BDD syntax, which stands for those words that we saw before. And yeah, it's a good combination. And now you're going to take a look in the test pyramid. So as you can see, this is a concept of a test pyramid, which says a little bit about how your application should be tested, where should exist the most number of tests is in the base, which are the unit tests. So the unit tests are cheap, and they're easy to write, easy to change. You can just have a bunch, and it's easy to run also. So it doesn't take a lot of time to run. And then as we go up, the tests become a little bit more expensive and is lower. So in the middle, you have the integration tests. And then on the top, we have the end-to-end tests. And a good thing about that is that because end-to-end tests are slower, and we want to have end-to-end tests into the top, it's a nice way of having both together really well. So we have a way of having few tests that are they can cover your user journey very well. So you don't need a lot because you're end-to-end tests. You want to focus on the user journey of the help path. You don't need a lot of tests. So let's discuss a bit about the test environment. As I said before, the end-to-end tests, they test the whole user journey or application flow. And because of that, the environment needs to be mature enough. So I would say that the best place to run your end-to-end tests are in this staging environment. So it's one step before production. And then it should cover at least the most important user journeys. So there are not so many tests because they are slow, as you can see in the top of the pyramid. And then in order to execute this in your daily life, in your company, in your squad, it could be applied in a CI/CD pipeline before deploying to production. So as soon this pipeline runs and everything is green, then you can go to production with this code. So now Cucumber in practice. What is Cucumber? So Cucumber is an open source tool for BDD. It supports multiple programming languages. You can use a lot of programming languages within Cucumber. It uses Gherkin syntax, and also it's based on step definitions. So these step definitions are the steps your user are getting through your application. So now you go to Google and search for Cucumber. First of all, you're going to find a lot of Cucumbers, and then you search for Cucumber BDD, and then you finally get a list of programming languages that you can use your Cucumber. So nowadays, we have this page which shows which languages are supported, and then you can see the small label for official, unmaintained, unofficial, and semi-official. So the good thing about Cucumber is that because it's open source, if you are working in a project that's not supported by Cucumber, you can create your own integration, just like this guy with D did, and also with Rust. They just created one repo and submitted a PR to Cucumber. They accepted, and now they are featured in their website. So it's pretty good. So to set up your Cucumber project, the first thing you have to do is to import the dependencies in your POM or Gradle you choose. For this project, I am using POM in Maven. So first of all, I just imported Cucumber Java and Cucumber JUnit. And then in my files, it was like this. So I have my test files, which are for the steps. I have my resources on the tests, which are made for the features that I want to have inside my application. And then in the top, I just put some helpers, so something I have to use in order to make my test runs, in order to make assertions to other applications. I do some API calls or something like that, database connections, you know. And now about Gherkin. Gherkin is the syntax, and it works like that. So each feature file you are writing using Gherkin, and then it's basically like that. You have the feature. So in this case, it's get to know our Spartans. I have some description, which is everybody wants to know details about our Spartans. Just to give a little bit of context about why we're saying about a lot of Spartans. Here in WAES, we have a private repository, which we have some information about us. We are the Spartans here because we are Spartans. And this is a test of this application. So when you see Spartans, you can see me or any one of these people here as co-workers. So we want to know about them. I can put the background first. So it's like a before each in JUnit. So every time I run a scenario, I want to run this first. So I am logged as admin. And then I go to my scenario, which is who is the oldest Spartan. So given a really old Spartan into the database is added. When I ask for the oldest Spartan, then I should receive the same really old Spartan. So I'm using the BDD syntax to write my feature files and using the Gherkin syntax. And also another cool feature about Gherkin is that you can use the scenario outline, so you can use also parameterized tests. So given the letter, when I ask for the Spartan that starts with the letter, then I should have a list of Spartans starting with the letter. And then I can just put a list of letters that I want to apply in this test, and then it's going to run parameterizedly. Other nice thing about Gherkin is that it's also open. You have some keywords in English, and then if you can map the keywords to whatever you want, other language, or even to emojis, you can add. So here, as you can see, we have Dutch language available, and we also have emoji language available. So it's focused on the clear communication in your feature files. Now about the steps. The steps are kind of mapping of our feature files with our code. So we have the scenarios, and also we have the words given when and then. And after that, I have a text describing which is this step. And for each one of these steps, I can have a map with using annotation to our code, actual code. And then, as you can see here, I add all special that old Spartan to the database. Then I just can map here, and then I write the code that relates to this description. And in order to use this, I can just put in a step package, and everything's going to work. So as you can see, I have a mapped to each one of these texts. And also, I can use the Lambda style. If I don't want to use annotations, I can also use Lambda. So instead of putting the annotations, I'm writing a function, an anonymous function there, that will also relate to my text. But for this, you have to import another package called Cucumber Java 8, so it has Lambda support. And now you're going to the live coding. Not coding, but a demonstration. Right. So here I have the project I want to test. Actually, it is this one. It's our Java Spartan service. And then in order to run this, I'm just going to go here. Because, yeah, I'm running this file, which has integration with test containers. And then I can just put a service connection, and then the PostgreSQL is going to get up and running. Yeah, it is there. It was fast this time. So here's a simple application. I just have a service that will reply to our requests about people. So I have some get oldest, get youngest, get first. I can also save new Spartans, get all, these kind of things. And then here, I have my files. So first, this is our POM. Is here where I have imported Cucumber Java 8, Cucumber Java, and Cucumber JUnit in order to run our Cucumber. I'm also using here RestAssured to make some assertions during my request to the other application. And yeah, that's basically it. So if I go here to our Spartan feature, I have the same example I had in these slides. So I have get to know our Spartans. Everybody wants to know details. And then I can just run the feature. Yeah, so it works. So here I have some report about the tests I was running. So here is the feature, and then here starts coming the scenarios. And you can see here that the background is always being the background is always being applied before each one of the scenarios. Yeah, so as you can see here, I log as admin. I add the really old Spartan into the database, which is old man da Silva. He's there. His age is 999. And then I ask him for the old Spartan, and then I can see here that he got from the API. And then I did the assertion, and then everything goes fine. Same thing about the Spartans with the letter. I can go there. So it's the same thing. I have these Spartans with the letter. Then I log as admin again. I have the letter F, and then I get in people with letter F, which is Fabio, Fausto, me. And then I should have a list of Spartans starting with the letter F. So we can check here that the contents are equal, and then I'm just filtering everything that starts with F, and then the assertion is being done. So everything is working as it should work. Yeah, so for the service, just checking, saying about the rest assurance. So whenever I'm doing request, I can also use the BDD syntax for this case. So it's really good to use in tests, because at the same time I do this request, I can assure that the content I'm getting is correct. So by using the syntax, I say, given I'm using port 8080, my content type is this, and my body is this. When I post there, the status code should be 200, and then I can log the body if I want. That's what I did here. That's why I have the body. And then I'm instructing it, using this as a content for my assertion. And I think that's basically it. So this is how you can write your features, map these features inside services, inside steps, and then apply it to your running application. Also, if you are really into this BDD thing, you can also check Cucumber Jira integration. So if you want to develop new behaviors in your application, and you can also ask for your PO to write the features you want properly. And then he can just create this Jira ticket, and then this is going to go to your GitLab or GitHub or whatever you are using. And then you just have to implement all the things that your PO described in this file, which is really kind of fun to try, I guess. And that was it. I hope now you know a little bit more about Cucumber than you know before. And that's it. Thank you very much, guys.
Questions? I have a question. So what do you do about the task coverage? So for example, let's say you have an E2E that's covering a few functions. Do you also have unit tests that are covering the same thing, or should you merge the coverage somehow?
Unit tests, you are testing your application inside it, right? And meanwhile, when you use end-to-end, you are testing the whole flow of not only one application, but the whole user journey. So sometimes, ideally, you should have unit tests for everything. And then the end-to-end tests will be a complement from outside of your application, just to make sure that your new deployment is not impacting the user journey. So it's going to be outside of the application. It's another application that's going to test your whole environment for the user journey.
So it's normal to have some overlap.
Yeah, it's
What kind of black box test?
Yeah, you don't know what's inside. You just know that given that, you want other thing, And then by using that, you know that the user journey is not impacted, it's complete, and everything runs properly.
Just to complement this, I agree with you, thinking about the end-to-end test. Right?
Yes, it's about
but you can use, and it's very common also use BDD and Cucumber stuff for component test, which is a concept that's it's between the integration and end-to-end. It's like I'm gonna test this application, but I will mock the external dependencies. So instead of having a proper end-to-end test, I will mock a database. I will mock this external service that I need to execute requests, and I will test the flow of only my application. So this is also useful.
Yes.
For instance, in my team, we have basically testing the flow of our application, mocking external dependencies, also works. But it's not end-to-end.
No, and I also defend that there's going to be overlap, even for this case.
Yeah, true.
Always.
I believe that you can even write for unit tests, right?
Cucumber. Yes, you could use Cucumber even for unit tests if you want. And also, JP has an article about this. He's using Cucumber in Kotlin application also, but instead of using two different projects, they just put the Cucumber dependencies inside that project and put another module, and then it works like that.
One question. When you are using this tool, the tests are isolated by default, or you have to isolate the tests?
What do you mean about?
Let's say that like you make a change to the database. Will the change still be in the database in the next test? Or?
Yes, in this case, yes. So if you don't want to have this change being propagated, you can also create a new hook inside Cucumber that you kind of fix what you did before, because it's outside. So it's like someone is using. So if someone bought a product, it's gonna be bought. It's not gonna be there anymore. So then if you want to fix that in your staging environment, you can just undo in the database directly or with another helper service. And then, it's not isolated.
Mauricio, when we have to run unit testing, integration testing, or end-to-end testing, most of the time we require to prepare the data. Just as we noticed, you have in the feature file the outline scenario with the table, but what is your suggestion to generate data automatically instead of just populate the table manually?
Yeah, I know there is a nice tool called Mokaru. You can generate data there. It's a random data, which is very usable in this kind of things. But yeah, in my last project, we were using end-to-end tests for authentication. So there we were creating manually some data that we were going to test against the staging environment. So you know that the login is working, and then our token can hit the service they should. But I would say to try Mokaru. But yeah, there are plenty of tools that you can use. This is one example.
The question from Lainers is,
Why did you choose Kotlin, and is there any reason specifically?
Yeah, it's fun, right? Because in the introduction, I said I like Java, and then I use Kotlin. But the reason was personal. I wanted to use Kotlin because I was really trying to study Kotlin, and I don't see many guides of Cucumber with Kotlin. It's more like with Java. So I really wanted to try and see how it is. That's why.
Any other questions? No? Then I'd like to thank you, Fabricio, for presenting for us.
Thanks, guys.
Just make sure. So I'd like to thank you guys that were online, you guys here. We're going to have pizzas, so I hope you see next time. Bye-bye.